Ever wonder what's actually powering the metaverse? Behind every virtual world lies a massive physical infrastructure of specialized servers that would fill multiple football fields. Much like how industrial food production facilities transform raw ingredients into finished products. In this video, we're taking you inside the hidden factories of the metaverse, the real-world facilities that make virtual reality possible. You'll see exactly how developers craft these digital worlds from the ground up, following systematic processes that mirror how manufacturers create your favorite foods, with each step carefully designed and executed with precision. You might think virtual worlds exist only in digital space, but every metaverse actually begins in massive warehouse-sized server farms. These technological giants are the hidden foundation of virtual reality, consuming as much electricity as small cities. When you're exploring a virtual landscape or interacting with other users, you're actually tapping into computing power that rivals some of the world's most advanced supercomputers. These specialized server facilities process millions of calculations per second, rendering 3D environments in real time while tracking every movement and interaction. The computing demands for metaverse applications dwarf traditional internet services. Streaming video requires processing a single data stream, whereas virtual environments constantly calculate physics, render graphics, process audio, and track thousands of simultaneous users. Major metaverse platforms rely on distributed computing systems with thousands of servers working in harmony. Each server farm contains rows upon rows of specialized hardware, arranged like assembly lines in food production facilities, with GPUs serving as the critical components. Like food factories maintaining multiple processing lines for continuous output, these GPUs handle complex physics calculations and real-time rendering that make virtual worlds feel solid and responsive. The vast physical scale of these warehouse-sized facilities creates enormous cooling challenges. The heat generated by these systems is staggering, comparable to hundreds of commercial ovens running simultaneously. To prevent overheating, these facilities employ cutting-edge cooling technologies, including sophisticated liquid cooling systems that circulate specially formulated fluids directly through server components. Some companies have built their data centers in naturally cold environments or underwater to reduce cooling costs. Reliability is paramount in metaverse infrastructure. When a server fails for a traditional website, you might see an error message, but in a virtual world, system failures cause entire digital environments to disappear. That's why metaverse data centers implement redundant power systems with massive backup generators and multiple internet connection pathways. The financial investment required before a single user can enter these virtual worlds is staggering. Major metaverse platforms typically invest over $1 billion in physical infrastructure alone before creating the first virtual asset. Beyond the billion-dollar server farms lies an equally complex challenge, creating worlds that feel real when they don't physically exist. Every time you touch a virtual object, specialized physics engines perform hundreds of calculations in milliseconds, determining if that digital apple should roll off a table or shatter like glass when dropped. This process mirrors how food manufacturers test product consistency, where both virtual and physical worlds require precise measurements to create predictable experiences. When developers build metaverse environments, they begin with bare-bones 3D models that form the foundation of everything users will eventually see. Using powerful software like Unity and Unreal Engine, designers start with basic wireframes before gradually adding layers of detail and texture. Many companies develop proprietary systems tailored to their specific virtual world needs, giving each metaverse its distinct feel. Traditional video games often use pre-rendered scenes, but metaverse environments must generate everything on the fly, just as a food processing line must maintain quality at high speeds. Developers ensure calculations happen in real time, similar to the difference between a perfect food commercial and a restaurant making each meal fresh while you wait. The physics governing these virtual spaces rely on sophisticated mathematical models that calculate how objects respond to gravity, detect collisions, and determine material properties. Like ingredients undergoing chemical reactions when cooking, virtual objects transform based on precise formulas that create the illusion of real-world behavior. Weather elements add complexity through millions of individually calculated particles, creating rain, fog, and smoke that respond dynamically to user interactions. Meanwhile, spatial audio technology calculates how sound waves travel and reflect, making footsteps echo differently in various environments, enhancing the sense of presence. Before users enter these crafted worlds, rigorous testing occurs with automated bots simulating thousands of concurrent users, much like quality control in food manufacturing facilities, identifying performance issues and physics glitches that might disrupt the illusion of a coherent reality. While automated bots test the virtual environments, the true heart of any metaverse experience is who you become inside it. Your digital avatar isn't just a pretty face, it's an intricate system tracking over 50 distinct facial muscle movements to transform your physical expressions into convincing virtual ones. This manufacturing process rivals the complexity of the most sophisticated food production lines, creating digital bodies that respond, emote, and move with startling realism. The creation of your virtual self begins much like sculpting, but with digital clay. 3D modeling software gives developers precise control over thousands of individual points that determine your avatar's shape. Each curve and proportion can be adjusted with surgical precision, setting the foundation for your digital embodiment. Jake Chen, a lead avatar developer at Metascape, recalls the moment everything clicked. "We spent months getting the eye movements right. When we finally nailed it, our test user actually gasped, seeing her expressions mirrored perfectly." A static model would feel lifeless, which is why motion capture technology is essential. Camera systems record human movements in remarkable detail, as actors in sensor-covered suits perform everything from walking to dancing. These recordings create a library of natural movements your avatar executes in the virtual world. When you raise your hand in real life, your digital self follows with convincing fluidity. The face presents an even greater challenge. Human expressions are incredibly nuanced. A slight eyebrow raise completely changes an interaction. Advanced facial animation systems analyze these subtle expressions and reproduce them digitally, allowing your virtual face to show everything from confusion to delight with remarkable accuracy. Your virtual clothing is equally sophisticated. Physics engines calculate how different fabrics realistically fold and flow as you move. When your avatar runs, their jacket flutters behind them. When they sit, their pants crease just as real fabric would. These small touches make the difference between a convincing presence and an obviously artificial character. Throughout this process, developers carefully avoid the notorious uncanny valley effect, that unsettling feeling when something appears almost human but not quite right. Some platforms embrace stylized characters, while others push for photorealism through improved animation techniques and detailed texturing. Behind those detailed avatars and immersive environments lies a digital maintenance operation that never sleeps. You might think once a virtual world is built, it simply runs on its own, but the reality is far more complex. Every metaverse platform requires an invisible army of systems and specialists working continuously to prevent the digital universe from collapsing under its own complexity. When millions of users converge in virtual spaces simultaneously, the technical challenges become enormous. Every footstep, hand gesture, and voice interaction from every user must be processed, synchronized, and displayed to all nearby users in real time. This requires sophisticated load balancing systems that work like a busy restaurant kitchen redistributing orders among chefs. When too many users cluster in one area, these systems automatically spread the processing load across multiple servers, preventing any single machine from becoming overwhelmed. While you're exploring virtual landscapes, dedicated security teams monitor network traffic patterns and user behaviors, looking for signs of attempted hacks or exploits. The stakes are high. A successful attack could compromise the platform and potentially expose sensitive user data. Alongside security, content moderation systems combine AI scanning with human review teams who work 24/7 to maintain community standards even as new forms of problematic behavior emerge. The metaverse requires constant updates that introduce new features and environments. Before reaching users, changes undergo rigorous testing on staging servers, where developers identify and fix problems without affecting the main experience. This methodical approach ensures updates enhance rather than disrupt the virtual world. Analytics systems track everything from user behavior to technical performance, generating valuable datasets that inform future development. During major events or launches, these maintenance systems face their ultimate test. When hundreds of thousands of users flood into a virtual concert or product release, every component must scale seamlessly to handle the increased load. Imagine a virtual stadium filling with avatars, each needing their actions transmitted to everyone else in real time. The technical coordination resembles orchestrating a complex symphony where every instrument must play perfectly. These high-pressure scenarios push the infrastructure to its limits, while showcasing the remarkable engineering that makes our digital gatherings possible. How will the metaverse reshape our everyday reality by 2040? Throughout our journey exploring this grand fusion of physical and digital manufacturing, we've witnessed both technological and conceptual transformations. Experts predict this virtual frontier will become significantly more refined, with 500 million people globally experiencing fully immersive metaverse interactions daily, a staggering number that highlights how mainstream these technologies may become. Rather than focusing exclusively on VR, industry leaders anticipate incorporating augmented and mixed reality tools, blending our physical and digital experiences in revolutionary ways. Just as we've seen convergence between digital design and physical construction, this evolution represents a fundamental shift in human interaction. The metaverse isn't just another platform, it's potentially the next evolution of connection, built on a foundation spanning both atoms and pixels, forever changing our conception of reality itself.